Welcome to our channel, my dear students. Today we are going to talk about the previous year, that is last 10 years CBSE Board Chemistry Questions Part 8, in which we are going to discuss about the halo, alkane and arene chapter. The question number 1 is, write the chemical equations when the methyl chloride is treated with AgNO2. That is silver nitrite. It's not nitrate, it's silver nitrite. As we know that it is a covalent compound. So here the lone pair of this NO2 group will come and attack this positively charged because it is an electronegative one. So because of that, Cl, which is having some electronegativity, that's what it pulls the electrons of this methyl group, so that it attains slight negative charge. By that way, it also got slight positive charge. Now these electron, now this center will be getting a positive charge. Now these electron will come and attack the positively charged carbon. By the way, it can form a bond. Because of that, I will be getting like this. That is a Ag. Here it is O. Here it is N. That N will come and attack with this methyl group. That is CH3. Because of that, the Cl minus will goes off. Okay, so here the Cl minus will goes off. By that way, it attains slight positive charge. Because of electron donation, it attains a positive charge. Now this will go and attack like this. So this will cleave as Ag plus and O minus. This minus, now I'll be getting a negative charge here. This negative charge and positive charge will form a compound that is called, the compound name is CH3NO2. Along with that, I have other product, like here I'll be getting, here if suppose this bond is getting break, so this head part will having negative charge, as we know that very well. If you don't know that, watch my previous videos. So here it got negative charge. By the way, it got positive charge. Here Ag plus and Cl minus is there. Along with that, I'll get a product like AgCl is getting. This is the question number 1. And question number 2, what is that? Bromobenzene is treated with CH3Cl in presence of anhydrous aluminum chloride. What is the name of the reaction? It's nothing but it is a Friedel-Crafts reaction. As we know that, so this is the structure of bromobenzene. So I'm going to take a structure of bromobenzene. So here it is a bromobenzene. Okay. Now it is going to react with CH3Cl in presence of anhydrous aluminum chloride, AlCl3. In presence of anhydrous aluminum chloride. Now what will be getting the product? I will be getting a 2 type of products. What are all the products? This is what I am getting the product. 1, 2 and 3. This is the bond. Suppose I will be getting a product like this. This is CH3 bromobenzene. If I am taking a bromobenzene, so suppose if I am taking a bromobenzene, I will be getting a product like what is that? So ortho substituted product I will be getting, and second product one is para substituted product. Suppose if I am having a bromobenzene, in that para position I will be getting CH3 group. Are you able to understand? This is what I am getting the product in the case of the above question, that is in Friedel-Crafts as alkylation. So let's see the mechanism, how it happened. So here, if I am taking a CH3Cl, the CH3Cl initially reacts with anhydrous aluminum chloride. So which goes as AlCl4 minus along with that CH3 plus. Now I will be getting formed electrophile. Now the electrophile is getting formed. Now the electrophilic substitution reaction will going to take place. How it happened? So nothing but here, if I am taking a bromobenzene in which bromine, so it's an electron donor group, so that it donates electrons. By the way, the electron may be shift like this. Because of that, I will be getting a structure like this. Because of I will be getting number of resonance structure. Because of donation, it got double bond and Br, and it also got positive charge. Because of electron donation, as in the case of this lone pair will gives, by the way this lone pair will be given to this, that's what it attacks positive charge. Now this position will attain negative charge. Now electrophile will come and attack easily to form a product. Which type of product I will be getting? So you just listen here. This bond is no change. There is no change in this bond. Here one double bond is there. Because of the Br and positive charge also be there. Okay. Now in which electrophile will come and attack to form CH3. Because it has negative charge, it has positive charge. Because of that one bond is formed, CH3 is there. But there is no aromaticity is maintained here. Now the aromaticity will be maintained because here once if we want to come as CH3, so it should has one H plus. Okay, so because C6H5Br, CH. Okay, one CBr. So C6H5Br, in all the places I have hydrogen. Like that also, in this place also I will have hydrogen. That hydrogen, because once this hydrogen wants to move, then only this CH3 will come and attack. Now this H plus wants to move. If hydrogen moves, it arrives. It leaves as H plus. Because of that, it leaves negative charge. Now this bond is getting breaked. How it is break? So here it want to neutralize as negative charge. By the way, it got positive charge. Now these positive charge and these negative charge will form a double bond here. Now I will be getting a product like this. Here one bond, one bond, one bond. One more thing, here is bromobenzene. Along with that, I will be getting a methylated product. So here this is a alkylation of bromobenzene, or nothing but it's a Friedel-Crafts alkylation reaction. The next one is, what are ambient nucleophile? Give an example. This was asked in the year of 2014. The first question also asked in the year of 2014, and this also asked in the year of 2014. What are ambient nucleophile? Because I will be taking, so what are ambient nucleophile? So the nucleophile contains more than one nucleophilic attacking center. So that will be called as ambient nucleophile. By the way, so here if suppose if I am having CN, C triple bond N, this is a compound, cyanide group. So here the carbon may contain double bond. So the carbon may contain, what is that, lone pair, and the nitrogen will also have a lone pair. So here the two nucleophilic attacking center is there, but any one of the center will come and attack the reactant to form a product, respective product. Suppose if lone pair of carbon will come and attack, by that way I will be getting cyanide as a product. If suppose the carbon will attack, carbon attack is there, at that time I will be getting cyanide as a product. Suppose the nitrogen lone pair will come and attack the reactant, by that way I will be getting isocyanide. By that way I will be getting a CN product, here I will be getting NC product. That is what isocyanide and cyanide is forming. So nucleophile contains more than one nucleophilic attack center. Even though it have two different attacking centers, any one of the center will come and attack the reactant to form a respective product. In this case, if suppose the carbon will donate electron, by that way it forms a product with the reactant to form cyanide as a product. If instead of that, if nitrogen gives electrons to the reactant, by that way it forms isocyanide as a product. And question number 3. This was asked in the year of 2013. Almost many questions are asked in the year of, by the way, to finding out the order of SN1 and SN2 and which one will react faster in SN1 and SN2. By the way, we have lot of questions in previous year questions. So let's give reason for the following. Ethyl iodide. I will be writing a structure. Ethyl iodide. C2H5I. This is ethyl iodide. And ethyl bromide. C2H5Br. So according to SN2 reaction, in the case, suppose if it is a SN2, so SN2, so the 1 degree will be reacting faster when compared to 2 degree as well as 3 degree, as we know the concept. So if you don't know the concept, please go and watch my previous video, then you'll be getting a good idea about this. So here, ethyl iodide, so ethyl bromide, so both are 1 degree. This is also 1 degree and this is also 1 degree. But now, which one will react faster? According to our rule, iodine is a better leaving group. Why it is a better leaving group? Because from fluorine, chlorine and bromine, here I am having iodine. Because of the structure, because of the size, chlorine will have better size, big size. Iodine will be having a big in size. So carbon iodide bond will be very weaker, so that it will be breaked easily. By the way, it reacts faster. That's what, if a nucleophile will come and attack, it leaves very fast, very quick when compared to bromine. That is what this ethyl iodide is most faster in SN2. And next question, haloalkanes undergoes nucleophilic substitution reaction, whereas haloarenes undergoes an electrophilic substitution reaction. Explain. This was asked in the year of 2012. Now, first of all, we have to find out the difference between haloalkane and arene. So, suppose I am taking a haloarene as an example. Say for example, if I am taking a chlorobenzene, it's a haloarene. Am I right? So, haloarene. I will be taking an example as chlorobenzene. Now, this negative charge, because it donates electron, because of donation, it undergoes resonance structure. Because of the resonance, it will be getting stabilized. And also, so suppose here it got double bond as well as positive charge, and one bond is getting break, it got negative charge. There is no change in bond. This also there is no change in bond. By the way, suppose if I am taking like this, what happened now? This negative charge will go and this will shift it like this. Now I will be getting another resonance structure. This has negative charge. This bond is getting break. By the way, it got negative charge here and one positive charge will move here. This positive and negative will form a double bond here. Now double bond Cl plus. There is no change in it. Another structure. How we can write? This bond will breaking now. This gives positive charge. This gives negative charge to this. By that way, the negative charge will shift like this. Are you able to understand? So here it is a negative charge. Here one bond is formed. Here one bond is formed. Here it is double bond. And Cl plus is there. And next step, I will be getting again chlorobenzene. What happened? Only the thing is the bond is getting shifted. By that way, I will be getting a same product. Now, because of the resonance, it got stabilized. First thing is, because of the resonance, because it has 1, 2, 3 and 4. 4 number of resonance structure is there. Okay. Because of the resonance, it got stabilized. And one more thing, if you look at in deep, so this ortho position and para position. This is also ortho position. So 1, 2 is ortho. 1, 4 is para. 1, 6 is ortho. Now ortho and para positions are electron rich now. The negative charge, negatively charged ortho positions are there. That is what, if an electrophile always having positive charge. Okay, are you able to understand? Electrophile is there. Now the electrophile will come and approach here. It easily form a bond. By that way, it forms ortho-para products. Suppose if it approach here, it forms ortho product. So ortho and para products I am getting, because that is what it undergoes only electrophilic substitution reaction, because of rich of electron center in ortho and para position. This was created because of resonance structure. Okay, but in the case of a haloalkane, suppose if I am taking haloalkane CH3Cl, if you consider, this is an example of haloalkane. Now what happened? So here it is a highly electronegative. Now it can pull the electron. Because of that, it negative charge, it got positive charge. Okay, now the nucleophile will come and attack. Now suppose if a nucleophile will having negative charge. This will approach a positively charged carbon. Okay. So this is the carbocation will come and attack. Are you able to understand? So now it forms an electrophilic center of carbon. That is what it will easy to attack by nucleophile. That is what this will be undergoing nucleophilic substitution reaction. Think so? Are you able to understand, student? So here, because of resonance, it got negative charge in argon para position. That's what the electrophile will having positive charge. It can easily come and attack. This is what it will be called as electrophile will attack. That is what is the electrophilic substitution reaction. But in the case of nucleophile, in alkane, it has positively charged carbon. That is what it will be susceptible to easily attacked by nucleophile. That's what is the nucleophilic substitution reaction will occur here. Okay. And next thing is, how will you convert the following? This was asked in the year of 2010. Benzyl. First one is the benzyl chloride. Benzyl chloride. This is the benzyl chloride. Structure of benzyl chloride. So I'll be writing a benzene and CH2Cl. This is the benzyl chloride. If it is reacts with aqueous KOH, it's nothing but a nucleophilic substitution reaction, because the substitution will be taking place. This will be acting as a nucleophile. This will go and attack this carbon, by the way it eliminates Cl minus to form benzyl alcohol as a product. By the way, I will be getting a product CH2OH, along with I will be getting a KCl as a product. Are you able to understand, student? And next one is a very important. So what is that? That is a methyl magnesium bromide. Methyl magnesium bromide, which will be getting converted into 2-methyl propan 2-ol. How will you write the structure? If we want to write the structure, propane 1, 2, 3 carbon atoms, 2-ol. So I'll be getting second position OH group is there. 2-methyl, the substitution will also be present here. Okay, now I can write CH3 here also, CH3. Are you able to understand? This is a 2-methyl propan 2-ol. If you consider this is 1, this is 2, this is 3 carbon. So second position I have methyl group, second position I have alcohol group. So 2-methyl propan 2-ol. So I will be getting a structure. Now we have to look at very clearly. So in reactant side we have how many carbon atoms? Only 1 carbon atom is there. But product side we have 4 number of carbon atoms. So we have to add minimum 3 number of carbon atoms to the methyl magnesium bromide. How will we convert this? So here methyl magnesium bromide. So I will be getting, as we know that methyl magnesium bromide here. If suppose if I am reacting it with CH3C double band O CH3, I will be adding a 3 carbon atom containing ketone, because the ketone only gives, when it reacts with methyl magnesium bromide, it gives 3 degree alcohol. Okay, now let's see the mechanism. Here it is CH3 minus, because it is a 2 plus and it is minus. Now the CH3 minus will come and attack this carbon. Why it attacks this carbon? This carbon is having slight negative charge and this carbon is having slight positive charge because of this oxygen. Now what happened? So this CH3, I am writing this one. C, one more CH3 will be coming, and here because of that it will be shifting like this. So O minus is there and Mg plus is there. That's what it attack from MgBr, and one more CH3 I want to write. Now this is an adduct. Now adduct is formed. So now the adduct is hydrolyzed. If it is involved OH. Now what happened? So this bond is getting break like this. So this will be formed H, this will be formed OH, for your simple explanation. Now what happened? So here I'll be getting CH3, C, here one more CH3 is there, and OH. Along with that I will be getting a product. What is the product? So here it is a MgOH, along with that Br I will be getting. Are you able to understand, student? So I think so you may get a good idea about this. Thank you so much for watching. Please go forward my videos to get benefit of others. Thank you so much for watching. Thank you once again. Please don't forget to subscribe my channel. Thank you once again. Thank you.